Section 1.2, first order linear differential equations. What is the general first order linear differential equation? Here it is. Y prime plus A of t y is equal to B of t. A of t and B of t are given continuous functions. Before we discuss how to come up with the general solution of this equation, let us consider a particular case of this equation, particular case when B of t is equal to 0. We call this homogeneous first order linear differential equation. Homogeneous means B of t is equal to 0. This formula gives us the general solution of such an equation. So the general solution of this equation is y of t is equal to c, where c is any real number, times exp means exponential function, e to this power. We raise e, the number e, to this power. Moreover, this symbol means a particular antiderivative. Well, depending on a situation, what is written here sometimes means the general antiderivative, but in this particular case, it means a particular antiderivative. And the reason why we use here a particular antiderivative is the following. Note that we multiply the whole thing by c. So there is no reason for us to put once again plus c here. It's not a mistake if you use the general antiderivative instead of a particular antiderivative here. It's just a redundancy because we multiply the whole expression by c anyways. Now, if you click on work, you can see how we derive this formula. Now let us talk about applications. So example number 1. Here is the homogeneous first order linear differential equation. So solution 1, let us apply this formula. In order to apply this formula, step 1, identify A of t. In our case, A of t is equal to 2t. So we replace A of t by 2t. Antiderivative of 2t is t squared, and the result follows. Y of t is equal to c times e to negative t squared. This is the general solution of our differential equation. When we say the general solution, we mean the following. This formula gives us all possible solutions of this differential equation. No matter what we plug in instead of c, the resulting function is a solution of our differential equation, and there is nothing else, which means if we find any solution of this differential equation, this solution can be written as c times e to negative t squared. Folks, any questions here?
What is y of t in respect of y prime? Like how, well, I guess I go look at the proof, but like how are they related?
Well, if I understand your question correctly, y of t is a function that we want to find. Y prime is its derivative.
Okay.
So looking at this, we want to find all functions that satisfy the following condition. Y prime plus 2ty is equal to 0.
All right, yeah, I got that. Awesome.
So if you replace y here and y here by this, means if first you find the derivative of this, then add 2t times this, you will get 0.
Okay. I understand that now. Thank you.
Other questions?
Is there anything special about this solution? Like, is it unique or something? Or is this just a solution?
No. This is the general solution.
Okay.
It's not a solution. This formula gives us all possible solutions. There is nothing left.
Okay, thank you.
Other questions?
When you said it was the general equation, does that mean there's special exceptions, or is that like jumping ahead?
So once again, when we say the general solution, we mean the following. This formula gives us absolutely all possible solutions of this differential equation.
Okay, thank you.
You can plug in any number instead of c. For example, if c is equal to 0, y of t is equal to 0. This is a solution of this equation. If c is equal to 1, y of t is e to negative t squared. This is another solution of this equation. Now, important, there are no other possibilities, which means if you find any solution of this equation, this solution can be written as c times e to negative t squared for some c.
Gotcha, thank you.
Any other questions?
For the scope of this course, will we always be differentiating with respect to t or x, or does it really not matter?
No, it depends. Sometimes our function is a function on x, sometimes our function is a function on t. It depends. Here it's clearly written our function is a function on t. Other questions?
I just wanted to ask where the e came from in the solution.
Well, excellent question. Your question is, how do we come up with this? Well, guys, this is one of the reasons why, along with solution number 1, I have solution number 2. No, the solution number 2 is much longer. However, solution number 2 gives us some insight why we have such a formula. Once again, explanations are written over here, but instead of going over these explanations, I would rather show you how this works in our particular case. So, reason number 1 for solution number 2 is the following. I explain why we have such a formula. Reason number 2, in solution number 2, in order to come up with a solution, I use a very important method which is called separation of variables method that we discuss in section 1.4. So what is written here is a preview of the method that will be discussed next week. So here's what we do. Step 1, copy this equation. Done. Next, college algebra step. Let us move 2ty to the right. Done. So the jump from here to here is just straightforward college algebra. However, the jump from here to here is actually pretty non-trivial step. No, that dy dt denotes the derivative of y with respect to t. All of a sudden, in order to jump from here to here, we think about this as about a normal algebraic fraction. We move 2t to the right. Question is, can we really think about this as about a fraction? Well, fortunately, the answer is yes. But in order to think about this as about a fraction, we have to impose a particular meaning to the top and to the bottom. Question is, what does the top mean? What does the bottom mean? The answer is, the top, dy, is a so-called differential of y. Now, folks, can anybody tell me what is differential? What is the difference between derivative y prime and differential dy? Can anybody tell me?
Would it be so if you think about it in like the basic terms of what a derivative is the infinitesimal movements in a straight line being put together at an infinitely small scale to create a smooth curve. Would the dy just simply be the movement in the in terms of y, of the y direction, without taking into account the movement in the t direction?
Okay, so folks, let us go back to calculus 1. We click on calculus, and then section 2.8, linear approximations and differentials. This is what we need. Click on this, scroll down. Please take a look at this picture. So, consider some function y is equal to f of x. Here is its graph. Pick some point x, go from this point up to the curve, and construct the tangent line. After that, consider a new point, x plus delta x. Note that according to what is written here, delta x and dx is same thing. So let us go to the right or to the left dx units from x. We start from x, and now let us consider a new point, x plus delta x, which is the same as dx. By the way, note that here dx does not have to be small or big. Dx is some non-zero number. Here's what we do next. We go from this new point up to the tangent line. And let us denote the jump of this tangent line by dy. We call dy differential. According to this picture, differential of y is the jump of this tangent line. Next observation. Note that slope of a line is rise over run. In our case, rise is dy, run is dx. So slope of this tangent line is dy divided by dx. But we know that slope of tangent line is equal to f prime. Conclusion, f prime is equal to dy divided by dx. Therefore, dy is equal to f prime times dx. This is exactly how we jump from here to here. We think about y prime as a fraction. Y prime is equal to rise over run. After that, we move dt to the right, the result falls. So, in short, differential dy is the jump of the tangent line. When we move from x, dx units to the right or to the left. Now, let us go back to this portion. Here we say, suppose y of t is not equal to 0. In other words, solution 2 consists of two parts. Case 1, suppose y of t is not equal to 0. Then we'll discuss case 2 when y of t is equal to 0. Here's why we split the solution into two cases. Since y of t is not equal to 0, we can safely divide both sides here by y. If we divide both sides here by y, we get this. And note that now, on the left-hand side, we have only y terms. On the right-hand side, we have only t terms. We just separated the variables. This is why we call this method separation of variables method. After that, we integrate both sides. By the way, the jump from here to here is again highly non-trivial step. I say highly non-trivial because know that we've never done this in calculus 1. In calculus 1, we have a function, we take antiderivative of this function, we integrate this function. Know that here we have quite an unusual situation. Along with a function, we have differential. How do we integrate the whole construction? But once again, mathematicians proved that if we have this, we can integrate both sides. Here's what we do after that. Antiderivative of 1 over y is ln of absolute value of y. Antiderivative of 2t is t squared. Next, our left-hand side is equal to right-hand side. Therefore, we can raise e to the left-hand side and e to the right-hand side. Note that e to ln of absolute value of y is absolute value of y. Next step, we rewrite this as the product of two expressions. And if we denote e to c1 by c2, we get the following. Absolute value of y is equal to c2 e to negative t squared. Next step. Since on the left-hand side we have absolute value, we can rewrite this as the following. Y is equal to plus minus c2 e to negative t squared. So, conclusion. If y of t is not equal to 0, y of t is equal to plus minus c2 e to negative t squared. Now it's time to consider case 2. Suppose y of t is equal to 0. What do we do? Well, it is easy to check that y of t is equal to 0 is again a solution of our given equation. Indeed, if you replace y here and here by 0, 0 prime is 0, 2t times 0 is 0, and 0 plus 0 is 0. So y of t is equal to 0 is a solution of this equation. And now let us put pieces together. If y of t is not equal to 0, y of t is equal to this. If y of t is equal to 0, then y of t can be written as y is equal to 0 times e to negative t squared. Therefore, no matter we have case 1 or case 2, y of t is equal to c times e to negative t squared, where c is now any real number. Once again, there is a difference between this and this. Know that since c2 is equal to e to c1 and e to any power is positive, plus minus c2 can be either positive or negative, but it cannot be 0. So over here, the constant in front of c is any non-zero real number. Over here, the constant is any real number, positive, negative, or 0. We come up with this combining formula number 1 and formula number 2. If c is equal to 0, we have formula number 2. If c is not equal to 0, we have formula number 1. Folks, any questions here?
Wait, how did we add the negative component if C2 is always going to be positive if it equals to e to the C1? Basically, how did we get to y equals to plus or minus? Where did we get the negative?
Oh, excellent question. Please take a look. Let us go back to this. Here we have
Okay.
absolute value of y. Here there is no absolute value. Think about the following. If absolute value of y is equal to 5, y is equal to plus minus 5. Same is here. Absolute value of y is equal to this. Therefore, y without absolute value is equal to plus minus c2 times e. Was that your question?
Yes. Okay. Yeah, I didn't see that. Thank you.
Other questions?
Do we always need to check if y is equal to 0?
No, that we cannot jump from here to here if y is equal to 0. Therefore, we split the solution into two cases. If y of t is not equal to 0, y of t is this. This is case 1. Case 2, y of t is equal to 0. So, if you use the separation of variables method, and at some point you divide by y, you have to split into cases.
I have one more question.
Yes.
When going through solution 2 and taking the integral of the left side, which is the one with the y's,
Yes.
why do we not add a constant there?
Well, good question. So your question is, when we jump from here to here, we add C1 on the right, but not on the left. Why is that? Well, you can add constant on the left and on the right. It's not a mistake. But be careful with that. If you add a constant on the left, you have to denote it, say, by C1, and then on the right by C2.
Yes.
Letters should be different. So if you decide to add a constant on the left and on the right, notations should be different. Say on the left plus C1, on the right plus C2. But then you can move constant from the left to the right and combine these constants, you will get fundamentally same as what is written here. You see it?
Okay. Yeah, I get it.
Next question is, what if we have a so-called initial value problem? Well, what is the initial value problem? Initial value problem means we have our equation and some initial value condition. So initial value problem is a combination of this and this. The solution of the initial value problem is over here. And now let us compare this formula with the formula that we just discussed. Please take a look at this. So, if we have just a single equation, then its general solution is over here. But if we have the initial value problem, then its solution is this. There are three differences. Difference number one, instead of C, we have y0. What is y0? It's from here. Difference number two, instead of indefinite integral, we have integral from t0 to t. What is t0? It's over here. Lastly, difference number three, since t is already taken, inside this integral, we should use some other letter. So, instead of t, let us put, say, s. Now, let us discuss an example. So, here's the initial value problem. Step one, identify a of t. This is sine. Identify t0. It's 0. Written t0 is 0. And finally, y0 is equal to 3/2. And now we apply this formula. We replace y0 by 3/2. We replace t0 by 0. And then we integrate the whole thing. Here's work. Antiderivative of sine of s is negative cosine of s. Minus times minus plus. Plug in t here, plug in 0 here. Done. And cosine of 0 is equal to 1. This is exactly what is written here. Folks, any questions here?
Could you go back to the work for the example problem? So I don't understand where the variable s actually goes.
So once again, it's a matter of style. It's not like a huge deal. The point that I'm trying to make is the following. If here, instead of s, you use t, it will be a little bit confusing. We'll get here cosine of t, where instead of t, we can plug in again t of 0. So it's a little bit confusing. Let us use a different letter. Let us use, for example, s.
Gotcha.
Then if s is equal to t, we get cosine of t. If s is equal to 0, we get cosine of 0. That's it.
Okay, cool. Yeah, I understand. Thank you.
Other questions?
How do you know that the bounds of your integral or whatever are 0 and t? Like, was that given in the question, or is it going to be like that always?
Excellent question. So please take a look at this. Here we have y0. How do we know what is y0? Y0 is the right-hand side. Here we have t0. How do we know what is t0? T0 is the number inside parentheses. The number inside parentheses is 0. We start from 0. If, for example, instead of 0 we have 7, then here we start from 7. Did I answer your question?
Yes, thank you. And if there was like a number for the top, or is it always just going to go to the variable?
On the top, we always have t.
Okay, thank you.
Other questions?
I have a question.
Yes.
For solution 2, and that's in problem, if you go down to where the integral is taken, why is there, when we take the values of t0 and t, wouldn't it be like cosine t minus 1? Since we have to like,
Are you talking about this portion?
yeah, that portion. I mean, the bounds are not shown in this problem, but we know that the bounds are t0 to t, which is 0 to t.
Excellent point. So indeed, there are two alternating ways to solve this problem using separation of variables method. Either we use indefinite integral and then use the initial value in order to find a particular value of C2, or instead of indefinite integral, we integrate from 0 to t. These are two alternating ways to solve this problem.
But would that solution give the same answer since the answer has
Absolutely
cosine t
same
minus 1?
answer. Absolutely same answer. One can show that the initial value problem has a unique solution.
Okay, thank you.
Now here's another example, example 2. We apply the formula. Before we apply the formula, we identify a of t, which is e to t squared. We identify t0, in our case, t0 is 1. And we identify y0, in our case, y0 is 2. And now we apply the formula, done. We don't do anything else, because one can show that an antiderivative of e to s squared cannot be written in elementary functions. So we are completely done here. Folks, any questions here?
I have a question. Questions like this where there's essentially no solution, or it's like a more complicated solution. We're going to see those on like quizzes and tests, stuff like that.
So, another excellent question. Very often students ask me the following: do we have to know for which functions antiderivative can be found, for which functions antiderivative cannot be found? Well, the answer is, on tests, I will give you multiple choice problems. So if you see integrals as multiple choice answers, then antiderivative cannot be found, or it's hard to find antiderivative. But if we have formulas without integral, then you have to do integration. Make sense?
Yes, thank you.